Okay, we are going to look at the exercise 4J question 6. Okay, A, prove that the inverse Laplace of 1 minus exponent negative 10s over 3s plus 1 over s plus 1 is equal to half of exponent negative 1/3 t minus half exponent negative t, okay, minus, okay, half of exponent negative 1/3 t minus 10 minus half exponent negative t minus 10 multiply ht minus 10. So we are going to do the part A first. So for part A, okay, we'll do the partial okay, we break it into two terms. We'll do the partial fraction for the first term, which is, okay, 1, in the partial fraction of 1 over 3s plus 1 over s plus 1. Okay, so notice we have, okay, two linear term. The numerator will be constant, so a over 3s plus 1 plus b over s plus 1. Then we do, okay, the cross multiplication, so a times s plus 1 plus b times 3s plus 1. Okay, since left side right side have the same, okay, denominator, after that we got 3s plus 1 multiply s plus 1, okay, we can, okay, cancel it. Okay, and we compare, okay, for the first linear term s plus 1, we'll substitute, okay, s equal to negative 1. So when substitute s equal to negative 1 plus 1, okay, a term will be 0. Okay, and then substitute s by negative 1, so you got negative 3 plus 1 will be negative 2b. Okay, hence, okay, b is negative half. Okay, b is negative half. Okay, and then, okay, for 3s plus 1, we substitute s equal to negative 1/3, so that the b term will be 0. So left side constant value 1. So when s is negative, okay, 1/3 plus 1, so you got negative 2/3, okay, a. Therefore, a is, okay, negative 3 over 2. 3 over 2. Okay, then, okay, okay, the partial fraction for 1 over 3s plus 1 over s plus 1. Okay, a is negative 3 over 2. You got 3s plus 1. b is negative half. Okay, multiply by s plus 1. Okay, and, okay, for the first term, we can factor out 3. Okay, negative 3 over 2 times 3. So you have s. Okay, factor out s. Okay, then 1 divide by 3. So that you get back 3s plus 1. Okay. So 3 and 3 cancel. That's why we obtain negative half of s plus 1/3 minus half of s plus 1. Okay, that's why, okay, the inverse Laplace of 1 over 3 times s plus 1, okay, will be equal to the inverse Laplace of negative half of s plus 1/3, okay, minus the inverse Laplace of 1 over half s plus 1. Where we obtain is negative half, factor out negative half. Inverse Laplace of 1 over s plus 1/3 is exponent negative 1/3 t. So this negative, factor out half. So inverse Laplace of 1 over s plus 1 is exponent negative t. Okay, then we already prove the first term. Because, okay, this one, you can break, okay, using linearity, you can break it into two terms, which is the inverse Laplace of 1 over 3s plus 1 times s plus 1. Okay, then the inverse Laplace of minus inverse Laplace of exponent negative 10s over 3s plus 1 over s plus 1. So, okay, you notice the second term is actually in the form of inverse Laplace of exponent negative as fs, okay, where the result you will get, okay, ft minus a ht minus a, where the a in this case is 10, okay, and then ft we okay, fs, okay, is the same with the first term. That's why the ft is, okay, the result here. So ft minus 10 from the t here, t replaced by t minus 10, second term t replaced by t minus 10, so the whole term here multiplied by ht minus 10. Okay, therefore in the second term, the inverse Laplace of exponent negative 10s, okay, over 3s plus 1 over s plus 1, okay, which is in the form of, okay, exponent negative 10s fs, okay, where the answer will be ft minus 10 ht minus 10. Okay, where you see the fs is same with the first term here, okay, that's why this is a, okay, this one is the fs, okay, this part is the ft. That's why the ft minus 10 will be negative half, okay, exponent negative 1/3 t minus 10, so minus half exponent negative t minus 10, okay, thing ht minus 10, okay, let me see, negative half, okay, one is positive, one is negative, okay, let me check, okay, okay, when s is negative 1, this one negative 3 plus 1 is negative 2b, that's why b is negative half, correct, okay, okay, when s is negative 1/3, so negative 1/3, oh sorry, this is positive, yeah, negative 1/3 plus 1, so mean 3 over 3 minus 1, this is, okay, positive, a is, okay, positive 3 over 2, okay, this is positive, this is positive, 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 this one is positive, positive, okay, so therefore, okay, therefore the inverse Laplace of 1 minus exponent negative 10s over 3s plus 1 over s plus 1, okay, will be half exponent negative 1/3 t minus half exponent negative t, okay, I mean these two answers add up together, so plus half of exponent negative 1/3 t minus 10 minus half exponent negative t minus 10 ht minus 10. Okay, so this is the question 6a. Question 6a. Yeah, we have proved that. Okay, question 6b. Question 6b. Okay, so figure question 6 below shows an RLC circuit with L equal to 3 Henry, R equal to 4 ohm, and C equal to 1 farad, which is initially at rest. So, okay. So I0 equal to 0. Okay, a power source of 5 volt is applied to the circuit for the first 10 seconds after 10 seconds, the power source is removed. Okay, that's why the ET for the first 10 seconds, it is 5 volts. So mean T, okay, for the first 10 second, okay, the voltage is 5 volts. After that, okay, this it is the power source is removed. So 0, okay, ET becomes 0 when T greater than 10. So this is a step function. We convert to unit step function. Remember, we factor out the top, okay, where function phi, and then takes the bottom, which is 0 minus top, okay. So okay, h t minus 10, okay, or phi minus phi h t minus 10. Okay, show that the RLC circuit, okay, can be moderate. Okay, here you got here right hand side phi minus phi ht minus 10. Okay, this is a RLC circuit using Kirchhoff voltage law. So the VL is voltage across the inductor, okay, and then VR is the voltage across the resistor, okay, plus, okay, VC is the voltage across the capacitor equal to ET. Okay, VL is L di dt, VR is IR. Okay, VC we got, okay, 1 over C integral, okay, I tau d tau from 0 to t, so equal to ET. Okay, plug in L, okay, given, okay, plug in L value, which is 3, so 3 di dt. R is, okay, R is 4, so you got 4I, so you get 4I, okay. C is 1, so you have integral of 0 to t I tau d tau equal to, okay, the ET here we have 5 minus 5 h t minus 10. Okay, so we have shown, okay, we have proved that, okay, this RLC circuit can be modeled as, okay, 3 di dt plus 4I plus the integral of I tau d tau from 0 to t equal to 5 minus 5 ht minus 10. ht minus 10. Okay, so we got 3 di dt plus 4I plus integral of I tau d tau from 0 to t equal to 5 minus 5 ht minus 10. Okay, then we'll, okay, later on we'll take the Laplace transform of the 3 di dt plus 4I plus integral of 0 to t I tau d tau equal to, okay, 5 times the Laplace transform of, okay, we got 1 minus ht minus 10. I factor out 5. So first step, take the Laplace transform after we get the model, okay, and then Laplace transform for 3 di dt, you got 3, so make sure you bracket. So this is s is minus I0. Okay, Laplace transform for 4I, you have 4is. Okay, Laplace transform for I tau d tau from 0 to t by using transform of integral, this will be is over s. Okay, you can look back the table of Laplace transform here. Okay, you got Laplace transform for I tau f tau d tau from 0 to t, you got fs over s. So I tau d tau will be is over s. Laplace transform for yt is ys, so it will be is. So di dt will be sis minus I0. And then for ht, where the a is 1, so you got 1 over s. Sorry, ht minus 10. So exponent negative 10s over s. Okay, so, okay, maybe here phi Laplace transform for 1 is 1 over s. Laplace transform for ht minus 10 exponent negative 10s over s. Okay. Later on, second step, substitute the initial condition I0 equal to 0 because the question says which is initially at rest. So when t0 I is 0, I0 equal to 0. Okay. So I0 equal to 0. So we left 3s is. Okay, plus 4is plus is over s, okay, equal to phi 1 over s minus exponent negative 10s over s. Okay. Third step, solve for the ys. Solve for is. We're solving for is. So factor out is at the left hand side. The term without is bring to right hand side. So first term you got 3s. Okay. Second term 4. Third term, factor out is, so left 1 over s equal to 5 times, you can hear 1 minus exponent negative 10s over s. Left side, right side you got over s. So this term we time s, we divide s. First term time s divide s. So that we got is. First term 3s squared. This second will be 4s. The last is 1. So divide by s equal to 5 1 minus exponent negative 10s over s. So we can cancel out, divide by s at left side, right side. Then you can factor out is, 5 times 1 minus exponent negative 10s, divided by 3s squared plus 4s plus 1. Then we can factor out the 3s squared plus 4s plus 1. So 1 minus exponent negative 10s. So 3s times s, you got 3s squared. So 3s, this one plus 1 more. So 3s plus 1s, so the 4s. 1 times 1 is 1. So we have solved the is is 5 times 1 minus exponent negative 10s over 3s plus 1, over s plus 1. The fourth step, taking the inverse Laplace, then we get the it is actually the inverse Laplace of is. Where we can factor out 5. Then the inverse Laplace of 1 minus exponent negative 10s over 3s plus 1 over s plus 1. Where from question 6a, we already obtained the inverse Laplace of 1 minus exponent negative 10s over 3s plus 1 over s plus 1. As given in the proof that they asked us to prove this part. From 6a, the proving part there. Here, 1 minus exponent negative 10s over 3s plus 1 over s plus 1. Is this answer. Therefore, it, this one 5 times. So this, the question 6a, you multiply by 5. So you got, this 5 times. I can put like this, 5. And the 6a answer multiplied by 5. exponent negative 130 minus, okay, half exponent negative t, or you want to expand 5 inside also can. So minus, this is half, okay, exponent negative 130 minus 10. So minus half exponent negative t minus 10, okay, h t minus 10, okay, the curly bracket, yeah, okay, or else, okay, you multiply 5 5 5 5. So this is the answer for question 6b. Let's check, okay, question 6, is correct. Mean the from question 5 multiply the answer by 6a, you multiply by 5. So that's why a curly bracket, okay, outside of this one, or you multiply this 5 over 2, I mean 5 5 5 5 here.